right. Now what we have understood is how a categorical dependent variable and the independent variable is related through what is called as sigmoid function, and this is the equation. As you can see, this equation is not a linear function, right? Like in MLR it is a linear function. That means per unit change in x will produce a proportionate change in a dependent variable y, whereas here what is the relationship between the RHS part of it and LHS part of it? It is not linear. So that means a proportionate change in x will not produce a proportionate change in y. Then what is the way out? Now what we are saying here is, in terms of multiple linear regression, if you remember, right, so whenever you want to read about logistic regression, so it is better to have an idea about multiple linear regression so that it is easy for you to compare and contrast. So if you can see that, so the dots are your observed data, and this is the best fit line that we have made it, and the distance between these dots, which is your sample data, and the best fit line is what we call it as error, right. So in this case y has, in terms of logistic regression, y has only two values, either 0 or 1. What is the error in y here, right? If actual class is 0, it can be classified as 1. If actual class is 1, it can be classified as 0, right. So this is the error term in terms of logistic regression, right. So which is very, very limited. So that's what is here. There is no error distribution. If you remember, for multiple linear regression there are various error assumptions. There are 4 error assumptions we have taken, and then we have checked it over there in the residual analysis. We usually do it, whereas here the error is simple. If it is a misclassified, then it is called error. There is no distribution as such. The error distribution of the outcome variable in logistic regression is not normal, right. There is no function called normal here unless in multiple linear regression, right. So and hence we can call it as non-linear also. Now because of this non-linearity, or what you call as no linearity with respect to the dependent variable and the independent variable, now the interpretation of the relationship between the independent variable and dependent variable in logistic regression becomes a problem, because it is not a linear regression, linear relationship. Because if in terms of linear regression, if you take it, it goes like this, you know. So beta naught plus beta 1 x1 plus beta 2 x2 plus so on and so forth, beta n xn. So this is a linear regression, right. Per unit change in x will produce the respective change in y, right. This is linear regression, whereas here this side is exponential and this side is probability, which is categorical variable. So where is the relationship between change in x and change in y? It's not linear, right. So because of the error distribution also. Now to fix this problem, right, understand there are two functions we are using and fixing this problem. First problem we had is categorical dependent variable, and hence we need to find a relationship between the independent variable, which can be metric and non-metric, with respect to the categorical variable, for which we went for sigmoid function. Now after going to the sigmoid function, only half the problem is solved, because I cannot interpret the relationship between the x and the y, that is your independent variable and the dependent variable. Then in order to interpret the relationship between dependent variable and independent variable, I need some other function which I call it as logit transformation, right. So I go for link function. This is called a link function, or what is called as logit transformation. So in quite a while we will see what is this. Using this function we try to establish a linear relationship between the dependent variable and the independent variable. Per se we could not able to establish as we can establish, as we would have established in the multiple linear regression, since we are going an indirect way of transformation, which is called as logit transformation. The logit transformation is used to establish a relationship between dependent variable and independent variable, and hence it is per se not a linear model. It is called as generalized linear model, GLM, right. So logistic regression does not come under linear models. It will always come under generalized linear model, because we are trying to make it as linear. Per se it is not linear. So that's why if you see any software, it will always will call as GLM, that is generalized linear model. Moving on. Now that we have understood logit function or logit transformation or a link function is the key for establishing a relationship between dependent variable and independent variable in a linear form, let us try to understand how it works. Now recall the equation, right? So where your LHS is your probability and RHS is your exponential, right? So this is the sigmoid function. Now in order to establish the relation between the dependent variable and the independent variable, what I am doing, I am taking odds, right? So from this I am taking odds, right? So what do? Pi I, or what is called as pi z, I divided by 1 minus pi I, right? So recall odds function, right, or odds is calculated by probability divided by 1 minus probability. Now here pi of x is nothing but the probability value, and hence I am converting into odds dividing by 1 minus pi of I, right? The same thing I do over there here in terms of RHS also, right? And after this transformation, the entire thing will go into e power exponential for beta naught plus beta 1 x1, right? So the equation, the above equation, when I change it to odds equation, the RHS will change into exponential of beta naught plus beta 1 x. Now this also does not establish a great relationship between the dependent variable and independent variable. So what do? They need to overcome this exponential, right? So otherwise the RHS is beta naught plus beta 1 x1 depending upon the number of independent variables. So here the independent variable is 1 and hence only x1 is there. Now this is linear, right? So but exponential is there. So how to take away this exponential? Then somebody said, as you might be knowing, when I take a natural logarithm, then this e automatically goes and it becomes ln of pi I divided by 1 minus pi I. So ln is nothing but natural logarithm, and whatever is inside pi I divided by 1 minus pi I, as you can see, odds equation is p divided by 1 minus p. So this is called as natural log of odds. So your LHS earlier was probability, that probability was converted into odds, and that odds was taken a natural logarithm so that your RHS becomes linear, right? So if you look at it, so this is linearized. Earlier it was in exponential of alpha plus beta x divided by 1 plus exponential of alpha plus beta x. Now in this case it is beta naught plus beta 1 x related to the LHS, which is your natural logarithm of odds. Now this is the final thing that we need to understand in terms of logistic regression, right? So this side looks like regression, but it is plainly not a regression. We have taken a logit of the pi, that is natural logarithm of odds, and hence this side is logit and this side seems like a regression. That's why we call this as a logistic regression, right? So this is the equation, final equation you need to remember. Logit of x is nothing but ln of natural logarithm of odds, ln of pi I divided by 1 minus pi I is equal to beta naught plus beta 1 x. So now if you look at it, RHS seems to be linear and LHS is your logistic function, and hence it is per se not a linear function, but we have generalized this as a linear function using the logit transformation, which is called as link function, and hence this becomes our final equation for understanding, and hence it got the name logistic regression.